Welcome to this explainer. Okay, today we're going to take something that, at first glance might look like a pretty dry mathematical abstraction, but we're going to translate it into a gripping, action-packed story of physical motion. If you've ever looked at a chart and just seen a bunch of jagged lines, well, you're in exactly the right place, because we are about to change how you see data forever.
Think about this for a second. Can a simple zigzag tell a complex story? Honestly, we often look at raw data and assume it's just numbers plotted in a void, right? Like it's completely detached from the physical world. But the reality is, every sharp peak, every deep valley on a graph, it's actually a footprint of something that happened in the real world.
Okay, let's dive into this. Here is the mysterious path we're going to decode together today. At first glance, sure, it's just a series of triangles, kind of like a zigzagging line bouncing up and down across a horizontal axis. But by the end of our time together, you're not just going to see shapes here. You'll literally see a high-speed vehicle pushing its limits, slamming its brakes, and throwing itself into reverse. Think of this as our anchor, basically the map for our entire journey.
Welcome to Numericals Studio, your online friend on the journey to crack IIT JEE and NEET. Join our community of students working together to secure top ranks. Don't forget to subscribe and hit the bell so you never miss out. Now, let's decode the problem of the day.
Okay friends, let's decode the motion from this VT graph. Friends, we all know that acceleration is nothing but the rate of change of velocity. So in our practical life, we have seen that whenever you press your accelerator, the speed of your vehicle increases, and whenever you apply a brakes, actually it decreases your speed. So whenever you are talking about an acceleration, there has to be involvement in the change of velocity. And you all know that velocity is nothing but a vector quantity. So if there is a change in velocity, either in terms of magnitude or directions or in terms of both, then there has to be some acceleration there. Okay. Now, before actually jumping into the problem, let us try to understand that what this VT graph can provide us. So friends, as you all know that acceleration is nothing but dv by dt. So if I just drawing a v and t graph, then the slope of v and t graph will give you the acceleration. Okay, this tan theta, this theta is nothing but the slope of the graph, and this is the height, this is the perpendicular, and this is the base. Then tan theta can be written as perpendicular by base. So this tan theta is nothing but the acceleration. See, in this direction that theta is increasing, that means slope is positive here. Okay, slope is positive. Similarly, if I just draw a graph like this, in this case the slope will be like in this direction. So this is the slope is negative. Okay, slope negative, that means acceleration is negative. Acceleration is negative compared to the velocity. That means you are talking about the deceleration kind of thing. Deceleration, that means you are applying brakes. Okay. One more thing that we get from the VT graph, that is the area under the VT graph. This area under the VT graph is nothing but the displacement or distance based on the whether you have calculated. We have calculated the area with sign or without sign. If you are taking the sign in account, then this area under graph is nothing but the displacement. Area under VT graph is displacement. Okay. So I think we are clear on the concept that is involved here. And see, I have also shown the concept of slope here. This is the positive slope, as I just told you. This is nothing but the negative slope. And this, in this case, this is a zero slope because there is no angle. So this is 0 degree. So this is a no slope. And what about this? If I just draw a vertical line, in this case, since there is no P, there is no B, that means slope is undefined here. This is slope is undefined. Okay. So friends, now let's collect this concept and jump into the problem and try to solve it. So you can see that velocity is spread over 0 to 10 meter per second and time is covered from 0 to 6 seconds. So see what happens in the first 1 second. In the first 1 second, if I just draw a vertical line over here, then this is the slope and this slope is positive, right? This slope is positive. So what is the slope? If I just calculate the tan theta here, then this is the perpendicular 10 by 1. 10 by 1 acceleration is what? 10 meter per second. What about the slope type? Slope type is nothing but the positive. So in this part, acceleration is positive. Acceleration is plus 10. Okay, what about from A to B? A to B, if you see, I just draw the slope in this direction. This is slope is negative. Again, you can see the tan theta will be again 10 by 1 only, but the acceleration will be now minus 10 meter per second. First, what about 2 to 3? In 2 to 3, see, it is going in this direction. Okay, it is already going in this direction. So what about this? This entire line is in negative. Okay, so that means again it is 10, because you can see it is 1 only, and this is again 10. So this is again acceleration is minus 10 over here. Okay, now from 3 to 4, what is happening? So 3 to 4 or 4 to 5 is again now, if you just draw the entire line, so this is again positive, and up to it has moved from minus 10 to plus 10. So this entire height is 20 by, and this timing is 2. So again this is 10 positive. That means acceleration is again positive in this part. So sometimes the vehicle is speeding up and then slowing down, then again speeding up, then again slowing down. From now calculate from here to here. Now again this is 10 and this is 516. That is again minus 10, right? So this is again negative. So if I just draw an acceleration versus time graph, then in that case, what will be the case? So if I just draw an acceleration versus time graph, so there will be a plus 10 over here, and there will be a minus 10 over here. So plus 10 remains for 1 second. Okay, this is 1 second. Now from 2 seconds onward, 2 to 3 seconds, it's almost negative. So suppose this is minus 10. Okay, now this is 1, 2, 3. Suppose this is 3. Okay, for 3 seconds it's all negative. So I can just draw a line like this. This is minus. Okay, I'm just joining the dotted line, so you should not consider the dotted line. You just have to consider this bold lines, which I'm just drawing over here. And then from 3 to 5, it's all positive. So let's up to 5. Again 10. Okay, up to 5. And then 5 to 6, it's again negative. Okay, so this will be the graph of acceleration versus time graph. If I just converting this VT graph into an AT graph, then this will be the case. Now what is the question? Question over here is that we have to find out first describe the motion qualitatively in the time interval 0 to 4. So we can describe the motion qualitatively that particle is accelerating for 1 second, and then it started deaccelerating for next 2 seconds up to 3 seconds. And then from 3 to 4 seconds, again started to accelerating. Okay. Now we have to find out what is the distance traveled. As I just told you that if you want to find out the distance or displacement traveled using a VT graph, you need to find out the area under the graph. So what is the area under the graph? That means the area of this triangle. Okay. So what is the area on the area of triangle? Area of triangle is nothing but half into base into hypotenuse, base into height. Sorry, hypotenuse I'm saying. Now this is the height. Height is 10. What is the base? Base is 2 into 10, so this is 10 meter. Okay, this is 10 meter. This is the distance travel, because we are not taking the sign. Okay, now what is the during 0 to 4? In 0 to 4, again this is 10, and this will again going to be 10 only. So total distance will be 10 plus 10, so 20. Okay, for this will be 20. But what about the displacement? Suppose if we just want to find out the displacement, then in that case, you have to take the sign of the area also, right? This is plus 10, and in this case, this is minus 10. So displacement is 0. That means particle is going forward for 2 seconds, and then it is coming back to the origin only. Okay, for 4 seconds. Okay, here to here, 0 to 2, and then again 0 to 4. So particle is again going back to the origin. Okay, so that means in this for 0 to 4 seconds, the displacement is nothing but the 0. Okay, they want to find out acceleration at half second. As you can see, the slope is constant. What do you mean the slope is constant? That means tan theta is constant. So at 1 second, whatever the slope is there, the same slope will be at half second also. So acceleration will be at half second is also equal to 10 meter per second square. What about the acceleration at 2 seconds? Acceleration at 2 seconds, exactly at 2 seconds. So you can see the acceleration is again constant, is deaccelerating. So at any instant, if acceleration is constant, that means what does it mean? It means that if you just take the acceleration at any point of time, it will be same. So acceleration at 2 seconds is nothing but, again, it is minus 10 meters per second square, because acceleration slope is negative. So friends, based on this concept, I have I'm providing you one more bonus question, and this is the question over here. You can see in this question what is required. You have to just use the concept again, same concept, and there is a VT graph shown before you, and you need to describe the motion first of all. So send me your answer. You can attach some files in the comment box also, and you can write your detailed answer, no problem in that. I'll be definitely happy to see that and reply you and give you a response. And you have to draw the corresponding graph of acceleration versus time. Okay, so how acceleration versus time graph would be based on the motion shown in form of a VT graph, you have to send me in the answer. Okay, so attach your screenshot, buck up, let's try to solve this problem using the concept that we have just learned, and it will be fun. Okay, let's make it more interactive. Friends, before signing off, I just want to thank you once again for your support. I just want you to give us enough motivation so that we can just keep bringing the new and excitement videos time and again. And thank you for your time. Have a great day.